Okay, let's try this third equation. Now, the first step in a third equation is to isolate the third, but this third is all by itself. That's pretty isolated. So now, how are we going to get at this 5 minus x? Well, we always do the opposite when we solve an equation. The opposite of square rooting is squaring. So you square both sides. The opposite of square rooting is squaring. So you square both sides. When you do that, weird things can happen. You can end up with what they call extraneous solutions, solutions that don't work. But if you do square this, you'll go x plus 1 times x plus 1, and you're really careful with it because you do FOIL, you get x squared, you get 1 squared, 1 times 1, but there's an inside and outside that gives you 2x. Now we add x to 2x, we add x to both sides, we take away 5 from 1, and there we've got to factor this. So we write x times x is x squared, 4 times 1 is 4, but we have to get plus 3x, so that's why we put the plus there. Plus 4x minus x, the inside and outside, they're going to give me that nice plus 3x. And now I'm looking at my two solutions, minus 4 and 1. But you know, they might not be solutions. I've got to check them. People often don't like to check, and I don't know, they don't want the marks. I don't know, they just don't do it. Well, all you do is take minus 4, put it back into the very original thing and see if it works. And you go 4 minus minus 4, that's the square root of 9, is 3. But that doesn't equal minus 3. The square root of 9 is positive 3 by convention. That's what we say. So that one just doesn't work. But 5 minus 1 does equal, square root of 5 minus 1, which is the square root of 4, does equal positive 2. So therefore, 1 is your solution. You throw out the minus 4 as a solution because it doesn't make the original equation true. And there's your third equation.